Hi everyone, we'll get started. So first up we have Graham Dumpleton, who's going to be speaking to us about implementing a decorator for thread synchronization. Graham is a local, he's the developer of Mod Whiskey, which is something you can use to develop Python web applications with Apache. Thanks, Graham.
Thank
you.
A
round of applause.
Okay, decorators. I did a talk a few years ago on decorators, and I think most of the room left with their brains exploding. This time I'm not going to do such a death-inducing one. This is more about usage of a decorator, how to basically write and do an interesting use case of decorators. And it's going to be about doing thread synchronization. If I can just get my timer to work. Yeah, good. So, thread programming. Anyone do thread programming? Hate it? Love it? One of the problems with thread programming is that you have to work with common data, which you have to access from multiple threads. So we start out with a very simple application for doing threading, multi-threading. I'm going to create a whole bunch of threads here. And from each thread, I'm going to increment a counter. And we expect to be able to see the result of that at the end of how many times the counter's going. But if we start out with the boilerplate here, I don't have anything with the task here yet, but I'll implement a task which is going to increment that counter I mentioned. I'm going to start up 100 threads, and they're all going to increment that counter. Now, at the end of that, I should get how many? 11, 100. So we have a problem here. The problem with multi-threading is that when you act on common data, you do not know when those threads are going to run. And if you need to, when working on that data, you might need to read that data, manipulate the data, and store it back, then multiple threads can be doing that at the same time. Now, it may not look that obvious that that's occurring here. Well, actually, no, it is, because I made self.value equals value plus 1. I could have used plus equals, it would have done it atomically, but because I've taken that value, manipulated it, and stored it back, we've got a problem, because multiple threads can have got that value at the same time and be incrementing it. So we need a way of synchronizing these threads together. The normal way that you would do this in Python or any language, you generally have a lock object. And what happens is each of the threads will acquire a lock, acquire the lock, that lends them, gives them exclusive access to run that particular part of code. They can do what they need to do, store back the result, release that lock, and only then does it allow another thread to actually do that operation. And that way they'll all run in sequence, they won't be overlapping, and we can get the correct result. Now in Java, they actually have a keyword for this, and it's called synchronized. And it actually makes it very, very simple. They don't have to fiddle around with creating a lock object and then actually acquiring the lock and releasing the lock. You can actually use this synchronized keyword and just apply it to a member function of a class, and it means then that any operations on that class instance under that will be locked. So it means that when I do my increment, it's going to lock that instance of the class, and I've got exclusive access to it. Makes it very, very simple to do it. And we don't have anything like that in Python. So could we do that? Could we implement a synchronized keyword? Now, the closest we're going to get to that beyond modifying the actual language is a decorator. So could we do this? Could we write a decorator called Synchronise, which we can apply to a member function like this, and have that same effect of locking the instance of that class so that whenever I have multiple threads call in, they're only going to do one at a time. So that's the goal of what I want to try today. Now with decorators, well, first off is that we need a lock. In Java, each object in Java essentially has an implicit lock on it. So when you're using this synchronized keyword in Java, it essentially is manipulating a lock that exists on that object or is created on that object. Now in Python, we don't have any such thing. So we need to have a lock object get created from somewhere. And when we talk about a decorator, usually what people do is I'll make it so that I have to pass in that decorator, or pass in that lock as an argument. So the problem with doing that is we want to apply this synchronized decorator to a member function of a class. We're limited of where that lock object can be. We can either put the lock object at global scope outside of the class, or we can put it inside of the class as a class attribute. And they're the only two places we can put it. So if we do that, we do get the correct result. But the problem here is that because the lock is a class attribute, it means that if we have many instances of this counter object, and I have threads operating on these different counter objects separately, when I lock that object for one counter instance, it's actually preventing that increment function on a different counter instance running at the same time. So it's not really achieving, it achieves the result, it's correct code, it doesn't give us incorrect results, but it's not efficient if you're actually going to have a lot of these things, counter objects at the same time. So passing in a lock object is not a good solution for this. So we can start to get a little bit fancy. We're not going to pass in a lock object to the decorator itself. Instead, we can pass it in our wrapper function, we can do a little fiddle. So normally when you have your decorator wrapper function, you just take the args and keywords args. But what we'll do in this case is we'll separate out that self argument. That is the instance of that counter object. And what we will do is we will look on that instance of the counter object and say, do I have a lock object there already? If I don't, I'll go and create one on it. Now you have a little potential for a race condition here. So what we're actually going to do is we'll check first. If there is one, great, we can just go ahead, we can try and lock it. If there isn't one, we need to create one. And the way we're going to do that in a synchronized way is we're going to use this thing called set default. So vars on self returns you self.dict. It's the dictionary of the attributes in that instance. Set default allows us to say, I want to retrieve the value from that dictionary, but if it isn't already in existence, I want to set it to the argument I'm providing. So my argument is that threading.rlock instance. So first time through, it'll end up getting set to that, and then that is in lock, and then I can lock on it. There is still a little race condition there. You could have two threads try and get through there with lock is none the first time. You'll get a redundant rlock created, but only one of them will win. So you end up with only one in the end. So we can do that all magic under the covers, and it means we can do that. Lock object's gone. So we're all finished, right? Done? End of talk? Not quite. So I've got that on a member function. That allows me to have a separate lock on each instance of counter. But I want to use that on a function as well. And this is where it blows up. Because we've special cased that so that it's taken a self argument for the instance, that doesn't apply to a function. So what can we do in this case? Now this is where we're going to go away from the normal way that people write decorators by creating nested functions with this functools wrap-s function to make some magic happen properly. We're going to change this to wrapt, which is a module I've written for doing decorators, which has the aim of helping you to write decorators that behave correctly. But that's for things like introspection and things like that. But it has some other interesting properties. So this is what the decorator looks like when you're using wrapt. So you have a wrapt.decorator, which we're going to apply to a wrapper function, and that result of that is your decorator function, which you can then apply. Okay? Now, it looks a bit different to what you normally see. There's no nested functions involved, and you get 4 arguments. Wrapt, which is the function that it's ultimately going to be applied to, so you'll be past that when your wrapper function is called. An instance, which I'll get to in a moment, and the args and keyword args. So very simple here. Usually you just call wrapt, pass it the arguments, and that is going to call that original function, or the function that was decorated. But what is instance about? And this is where wrapt is really cute. It can give you contextual information about the context in which the decorator has been applied. So if instance is none, I know that it has been applied to a function, a normal global function, or a static method. If its instance is given an actual object, it means that it has been applied onto an instance method of a class or a class method. In the case of the instance method, it will be an instance of the class, and the class method, it will be the class itself. So we can actually do a bit of extra inspection to be able to determine when we're being applied in these 4 different cases. So on an instance method, a function or a static method, a class method, or even actually on a class itself. Okay? So we can use that fact in that original one I did where we were special casing self. We can instead use this instance to check whether we're on an instance or a function. Now, if we're being applied on an instance method, instance will be not none. So I can get that dictionary, we're going to put that lock object off that instance of that class. If it's none, I'm going to put the lock object on the function instead. But the rest of the logic essentially is still the same. We're going to create that lock if needed and lock it. Lock it when we do the call. And you can see this, that if we do some checks, we can actually apply that to a normal function, which is what didn't work before. We can go in there and introspect the actual function. You can see that there's a lock object in there now, and we're all good. In the case of an instance method, same deal. We can apply it on an instance method, and again can look at the lock object in there that gets created for us. Now, we want to make sure, though, that it is doing the correct thing. So in this case, you can see that if we actually look at the class itself, there is no lock object there. So we haven't done the wrong thing. It is on the instance method, or on the instance, I should say. So yes, I was looking at the instance there, and it's not on the class. So it is per instance, so that's good. That's what we want. Now, what about static methods? We can do the same thing. Put the synchronized decorator outside the static method decorator. In this case, there is no instance, there's no class, and so the actual lock gets put onto the static method itself. And what about class methods? Fortunately, this one blows up. The reason for this is that when you apply it to a class method, you're given, as an instance, a class object. Now, when you access the dict of a class, it's not actually a dict. It's what's called a mapping proxy. It behaves exactly the same as a dictionary. It lacks this set default method. So how do we get around this? So we're going to get a bit more complicated here. We can't use this get set default. So what we're going to do is we're still going to use vars to get that dictionary, but we can't use set default. Now, we're using set default as that way of giving an atomic operation for updating and putting that lock in there in the first place. So instead of that, what we'll do is we'll just create a global lock for this one operation, which will be on the synchronized decorator, and we'll lock on that instead. And that allows us to lock on that. We don't need to worry about using set default. We will do here actually 2 steps. We still have to worry about do I have to worry about a bit of a race condition, or have I mucked this code up? I've probably mucked this code up. I've got an extra line there we don't need. But we use that extra lock to do the lock, and that means we can actually update then that lock. But that mapping proxy is not a dict. I can't just assign it in as an item. So what we actually have to do is use setatter instead. And that way it does the correct logic of going in and setting it in the side of the dict for us. So we do that, to make that change, everything works fine. In this case, the lock is on the actual class. Okay? If we go back and check our class method, it's not there. So it did end up in the correct spot that we wanted. We look in terms of mixing these things. We want to make sure it's going to work. So we've got a synchronized decorator on an instance method, one on a class method now. So if we call these in the order of, let's call the one on the class method first. The lock is on the class. If we call it then the instance method, there is a lock on the instance method or on the instance, but very importantly, it's different to the one on the class. We need to check this because if you know how class attributes work, if you've got a class attribute and then you try and access it inside of a method using self, it will give you one in the class. But if you were actually to assign self.attribute, which with the same name as the class method, it creates you then a local copy in the instance. So this just makes sure that we are actually getting the correct one here. and it didn't accidentally fall through and use the one in the class instead. So here's the end result. We have a synchronized decorator. We can apply it to a normal function, and means that the locking is on that function. If you've got two different functions, they'll each have their own locks. If we have it on the instance method, you lock on the instance. If you lock on the class method, it locks on the class. If you lock on a static method, it is again on the static method. And you can also lock on the class itself. Well, I'm not quite sure why you'd want to do that. If you lock on the class, you're effectively locking on the calling of new or init dunder methods in a class. So you're locking on the operation of only allowing you to create one instance of the class or construct one instance of the class at the same time. But we're not quite done, because Java's actually got this other way using synchronized, the keyword. And that is that you can lock on a particular block of code. When we think about Python, the equivalent here is context manager. So can we do this as well? We've got a decorator, that was easy. But now we want to actually use the same synchronized keyword. Well, I'll call it keyword, it's just a name. But use it as a context manager at the same time. So how can we do that? So what we'll do first off, we drop down and look at what's happening when we create this decorator. When we put this synchronized on, I showed you the implementation of it, but you weren't able to see what was really happening. What ends up happen is the function gets replaced with an instance called a thing called function wrapper. So we can actually get rid of that wrap.decorator and do this ourselves. This is the equivalent. I'm essentially saying funct equals function wrapper of function wrapper. That's effectively what wrap.decorator does when you boil it all down. So can we use this? To make it a little bit simpler, I've refactored my code here to try and make it a little bit easier. If we work from the bottom down, instead of our synchronized decorator now, we've just got a normal function, which is going to take our function to be decorated. We're going to create that function wrapper. Our wrapper is, again, a separate function here. And inside that, we're going to go with synchronized lock. So I'm going to now separate out the creation of that lock into the top function, synchronized lock. And it's basically what we had before. And we'll only create that lock if necessary with the appropriate locking and so on. So we've refactored it. Now let's see if we can now get a context manager into this. So what we're going to do is look at the synchronized function. Now originally it was creating this function wrapper. So what we're going to do is now create a class called FindADecorator, which derives from function wrapper. So if we call that, it's just going to, that argument, the wrap function, will get passed to the dunder init of the base class. And it'll be just like we had before. But in our derived class, we've added in a underscore enter and underscore exit. They are the two special functions which are used when you do a context manager. At the start of the block, it calls enter. Exit of the block, it calls exit. So what we do there is that in the enter, we'll get our lock, remember it, acquire it, and then in the exit, we'll release it. So that allows us to do that. And we can mix it too. So we can say on an instance method, we've got synchronized decorator, but we can have another function which uses as a context manager on just a little bit of code. And this allows you to be more granular about where you apply your locks. Okay? And it also works on classes. So we can apply it to class methods as well. And it all works as one would expect. So, decorator, context manager. Can we do anything extra here? Remember how originally if you had two functions and you applied the synchronized decorator to each of those? Each has their own separate lock. But what if you did want to have two functions use the same lock but not put them in a class? And you did that. So we want to be able to do this. Create the lock ourselves, pass it as an argument to the synchronized decorator. So now we've got decorator, context manager, but now we want that use of that synchronized decorator to have an optional argument. So we do or don't provide it. If we don't provide it, it'll put the lock on the function. If we do provide it as an argument, it'll use the lock we give it. Okay. So in the synchronized function again, so down the bottom we have final decorator. That's our context manager case and a normal case. In the top one, we're going to take the wrapped object, which in this case actually is going to be the lock object. We're going to look and see whether it's going to acquire and release, so it looks like a lock object. And in this case, we are going to have another decorator function, which, if it's a lock object, will go fine. We'll apply a normal type decorator, not a weird one, to the original function. In that case, the wrapped argument to that synchronized lock wrapper will be the actual real function you want to decorate. And when it gets called, it'll go with lock, which will do the normal acquire release of the lock and call the wrap function. So we've got another one in there. So could we also do that with this context manager as well? Now, here we're getting a bit overboard here because I could just do with lock, okay? But if you're going to sprinkle synchronized everywhere anyway, why not, right? Because at least then someone who's learning this just learns one paradigm. Just use synchronize everywhere and all will be happy. So why don't I try this one now? It's more fun. We add a bit more in here. So we're going to focus on the top bit again. So what we're going to do this time is that instead of just returning the synchronized lock wrapper, which is the thing that would get eventually applied to the function you're applying a decorator to, we're going to create an instance, new class called partial decorator. And I know they're really bad names. It's going to derive from something in wrapt called a callable object proxy. Now, what an object proxy is, think of it as a wrapper that you can apply around anything, and you can use it as if you're using the original thing. So what I call a transparent object proxy. So if I wrap this around a dictionary, I can still use my thing as a dictionary. But what it allows me to do is because I can then derive from my object proxy and override methods in that. So if it was a dictionary, I could override the get item underscore method of dictionary, which is what does the lookup, to do extra little magic. So in this case, I'm going to use the fact that an object proxy and callable object proxy is essentially this transfer thing, which otherwise just passes through everything. And I'm going to add in the context manager functions of enter and exit to that derived one. And I'm going to wrap my decorator with that. Okay, have I totally lost you at this point? The slides are there, so you can always go back and go through it nice and slowly. But the end result is we do get what we want. Okay, trust me. So I can have a synchronized decorator with argument, with a lock argument, two different functions, but I can also use it as a context manager. Even though I could have done with lock, okay, but it looks cute. Now, you don't have to do all this yourself. There is my wrapped library. I have this synchronized decorator in there as an example, but it is a usable example. It does work. I don't know how many people use it. I use it myself in some other stuff, but it is there. And if you're not familiar with wrapped, it is a package which is intended to help you write decorators and get everything correctly. Because if you do use decorators and you use the normal nested function with functools wrap-s, there are various corner cases where it doesn't work. And we also covered those cases where if you want to know what the context you're used in, you can't easily create a decorator in the normal way which can know the context it's been used in. So wrap handles all these things for you. So do use wrapped. And that is where you'll find it. It's up on PyPy. And there's some docs in read the docs and also the main repo. And I think that is it. Oh yeah, I used this talk at another conference. I was just plugging some books I've got. You can get them with ebooks at that address if you're really interested. They're on OpenShift and Kubernetes. I was meant to take that out. So that is it. I don't know how we're going for time.
About 5 minutes.
Plenty of time. Okay. Well, I was expecting to go the full 30 minutes, so we said didn't have questions. So if there are any questions, I'm quite happy to take them because we've got a few minutes. Caleb up the back. It's Caleb, isn't it? Yeah.
So how do you test that? Do you use fuzzing and tricks like that to cover the corner cases?
I do have a test suite for wrapped. I don't know whether you've looked at my mod WSGI code. You will not find a test suite in there. But wrapt does have quite a big test suite. It's only testing the basics of some of those checks that you saw me doing there in terms of making sure the lock objects existed, were in the right place and that. So it's not doing a lot of load testing for concurrency issues and things like that. I've done my basic testing in the unit test. I've probably done a bit separate, and yeah, fingers crossed. But I don't know of any issues. Well, actually, there is one little funny issue which I've fixed and I haven't pushed it up, but it's just to do with remember in that side of that set default, it was creating a dummy, creating a lock, and sometimes you'd have more than one. I originally thought that was actually going to be one overall, but it's actually one per situation. So I fixed that. I just haven't pushed the code up because I've been bad.
The option of of passing a lock into the synchronized keyword, why not just also support passing in any object?
Yeah, I thought of that. Well, no, the original code effectively handles that. You could pass an object. It'll probably appear as a self, like an instance. Yeah. So yes, but I just did it as a lock explicitly, and I guess the reason for that is it's not so much a lock, you are doing it on acquire release. So technically you could use it on other synchronization primitives. So for example, is it the semaphore, which allows a definable range of the number of things you want to go in at the same time. So I did it that way so that you could use some of the other different synchronization primitives that have different semantics than just one at a time.
So Graham, that shares the lock between like if you had it applied to multiple instances of the same, multiple methods of the same instance.
Yep.
That shares the lock between those, like it's one lock per instance. Is that right?
Instance of the class, yes.
Yeah. Could you have it so that you have multiple, like different locks for different methods? So you have method A gets a lock and method B gets a different lock, or would you need to explicitly pass in a lock object for that?
That gets hard because, again, we get to the problem of the only place you can put the lock object, if you're going to pass it as an argument, is inside of the class attribute or as a global. Now, this actually is an interesting one because I don't know if you talked yesterday on decorators. I did this way, and I didn't even think that there could be other ways of doing this. And in the talk yesterday, he talked about using a weak key dictionary, I think it was. If you do that, and sort of start to use that way of doing it rather than storing as it on the instance using weak value dictionaries. One option might be that you pass in an argument instead of a lock object, you pass in a string, which is a name. So technically, if I do that, then the value to my weak key dictionary, what it was, could be instance and name or something. You have to be careful about it because of the weak ref stuff. But I could have it being. I could use separate names. So technically, maybe I could implement it to actually take a string so that in one class, you could have different named ones so that you could have different sets. So maybe it may be possible. I can't do it now, but after I saw the talk yesterday, it may well be possible. Maybe I'll do that as an exercise later. Okay, any other questions? Okay, so that's it. So later on today, I'm hoping to get a lightning talk in as well, which will touch a little bit more on wrapt. We'll see whether they accept it. Okay, thank you.